Today's topic is going to be how we can change from common language to algebraic expressions and vice versa. Some algebraic exercises on some books are presented as text and not as numerical or algebraic expression. So it's very important for us to know how to transform from text to a coefficient and variables. That's why this topic is also very important because many exercises on books are presented as text and we need to change them to letters and numbers. The most common variable that we are going to use is x. I mean, we can use every letter, but the most common used letter is x. So when a specific exercise is telling you about any number or a number, it's very common to put x. If we have a exercise in a book that it says a number or any number, that will be x. So let's see some examples. Today's class is going to be very easy one, but it's very important also, so put attention to the next exercises. So let's see these specific ones. The triple or the double of a number, it's very simple to do it. In this case, the triple of a number, that will mean 3 times a number that we don't know specifically which one is, so 3 times x. 7 times a number, that will be 7 times x because it's our variable. We don't know how it's or the specific quantity of x. The next one is 9 times a number, so it will be 9 times a number less 5. The next one, it says the third part of a number. So this is important because we can put it like the third part of a number, but we can also put it as the third part of a number. Both of them are correct. So it's up to you to decide if you use 1/3 multiplied by x or x over 3. It's the same. Both of them represent the third part of a number. Let's see some other examples. So let's see these exercises. A number plus 8, that will be x plus 8. The next one, it says the double of a number, less 5 quarters. So we can represent it like that. The next one, it says the seventh part of a number, the seventh part of a number plus 2. Remember, we can also put this the seventh part of a number plus 2. Both of them are correct. Let's see the next one. The sum or addition of a number and the half of the same number. So it's going to be x, the sum of a number. Let me erase this. It will be the sum of a number plus the half of the same number. We can also represent it as x plus the half of the same number. Both of them are going to be correct. Let's see some other examples. So if we see these specific examples, they are talking about two numbers. So we saw like when we are talking about a number, we use x. So when we are using two numbers, we are using x and y. Normally you can use also two different letters, but the most common use is to use x and y. So in this case, the first exercise says the product of two numbers. So remember, we can put maybe x multiplied by y, but we can also put it without parentheses, only x, y. In the next one, the quotient or the division between two numbers, it's going to be x divided by y. The next one, it says, look at these two of them because they can get a little tricky. On the first one, it says the sum or the addition of two numbers squared. That means the addition, it's the one that it's squared. This is number 2. In the other one, it says the sum of the square of two numbers. That means each number is squared. This is very important because there are different things. The sum of two numbers squared or the sum of the square of two numbers. So this is very important. If you have any questions, please ask me, but it's different. The sum of two numbers squared, it will be x plus y, in parentheses squared, or the sum of the square of two numbers, it means each number squared. Let me see the next exercises. So let's see the next one. The square root of a number, that will be the square root of a number. The next one, it says the subtraction of two numbers, so we can represent it like this. The next one, it says a number over the same number less 3. The next one, it says the product of a number and the same number plus 2. So this is going to be our answers. Let's see some other exercises. So let's see the next one. 3/4 of a number, that means 3/4 of a number plus 5/6 of another number. So let's see the next one. 12 times a number less 5 over 7 times another number. So we can represent these ones as the ones that I'm showing on the board. Let's see other examples. So let's see these exercises. The sum of two consecutive numbers. So what's a consecutive one? A consecutive one is the next number. So if we have x, if consecutive one will be x plus 1. This will be the consecutive one. So we will have here x plus its consecutive number, x plus 1. In the next one, it says the product between a number and its consecutive pair number. To obtain the next pair number, we always need to add 2. So x, its consecutive pair number, it will be x plus 2. Consecutive pair number. So in this case, we will have the product between a number x and its consecutive pair number, so it will be x multiplied by x plus 2. Let's see some other examples. Let's see, we can also represent equations. In this case, we have 5 times a number less 5 equals 1/3 of the same number plus 2. Remember, we can also represent this specific one as x over 3 plus 2. So both answers will be correct. So that's how we represent 5 times a number less 5 equals 1/3 of the same number plus 2. Let's see some other equation example. So let's see this exercise. It says 7 times a number less 4 over 2 times the same number plus 6 equals to 11/15. So we can put an equation only by reading this specific exercise. So this equation means 7 times a number less 4 over the double or 2 times the same number plus 6 equals to 11/15. Now we will see backwards how to transform from algebraic expressions to common language. Let's see. On the first example, we have 3x minus 5. We can represent it as 3 times a number less 5 or minus 5. It's the same. In the next one, we will have 2 times a number plus 3 over the same number. On the next one, we will have the product of a number minus 5 and the same number here is plus 5. Remember, I made a little mistake. Number plus 5, and in the other one it will be the same number minus 3. So this will be how we represent this product, the product of a number plus 5 and the same number minus 3. So let's see, in this exercise we have 7 fifths of a number minus or less 3 halves of another number. Let's see the next one. We will have the sum or the addition of 2 times a number and 3 times another number I'm sorry, here I made a mistake. The square I'm sorry, I was a little confused. This one, it says the sum of 2 times a number and 3 times another number squared. Because if we put the square of, it will be the square of a specific one. In this one, it's an equation, so it will be 3 times a number minus 7 equals 1/5 of the same number. Remember, this specific equation, we can have it like this, or we can have it also like this. It's the same one. So let's see some other example of equation, and that will be it for today. In order you can do activity that it's up of this topic. Let's see the last example. So let's see, in this case we have 2 times, this will be a long one, 2 times a number less 7 over the same number minus 5 equals to 4/3 of the same number minus 1/2, and that will be it. So now you have all the information needed to see and do the activity that it's called from common language to algebraic expressions and vice versa.